Hello, so we'd like to look at a few review questions from Algebra 2 and Trigonometry. Let's get started here. So which is a solution for this expression? Now, one of the things which we can do here is this. Since sine theta is common, when you factor out sine theta, we will have sine theta plus 4 is equal to 0. Now, notice. The sine theta can be equal to 0, yes, when the angle is equal to 0 or pi. But sine theta can never be equal to negative 4 to make this parenthesis equal to 0, so we are looking at any one of these two as our answer, which is choice number 3. Alright, number 7. Here we have angle has to be between 0 to 360. How many values of the angle theta satisfies this one? Now, since they're saying that how many, only thing that we need is to graph them, then we'll be able to see it. So here I'm going to have y equals and I'm going to type in 3 sine, in this case we're going to have x close parentheses and square. This basically means I'm looking at sine 3 sine square x, that's what it means, plus sine of x minus 2. Now I have to set the window from 0 through 360. 0 through 360. Now I'm going to go for zoom fit, try to see the best picture, which is zoom number 0 here. Oh, see, we get to see this relatively ugly picture because we forgot to set the mode. Let's set the mode into the degrees. And then we're going to graph it one more time. As you can see, we have 1, 2 times. It's quite clear. This one is not quite sure, so we're going to try to zoom in this section. Zoom in number 2. And I'm going to zoom in. I'm just going to go nearby those values. And then this one seems to be a little bit closer, so let's try to zoom in a bit more. Over here. So let's zoom in once again. It seems like there's one place where the graph is touching. So therefore, we'll be looking at 3 becomes our answer. Now here, which value satisfies this equation? Once again, one of the easy thing which we can do is sketching it. But I'm sure sketching will be quite easy, so we're going to try to do this one by hand this time. So once you try to factor this one, we get to realize that factoring will be 2 sine theta and sine theta equals to 0. Here to make the negative 5, we're going to have negative 3 here, positive 1 here. Then here we get to realize a sine can never be equal to 3, so this will be just, we can forget about that one. Here sine theta has to be equal to negative 1/2. When do you have sine theta to be negative 1/2? When theta is equal to, yes, 210 degrees or 330 degrees. So we can realize that the answer must be choice number 2. So we are looking for the value that satisfies this given equation. So we're going to have cosine theta is factored out to cosine theta minus 1 is given. Here cosine to be equal to 0 when the angle is 90 degrees, which is pi over 2, or 3 pi over 2. Now, When do you have cosine to be? We don't have none of these two as our answers. When do you have cosine to be in this case? 1/2. That's right. The angle has to be then. Basically, this is equal to 60 degrees, which is pi over 3. Or negative pi over 3, so which is what? 5 pi over 3. Then we have the answer right over here. Now, here, in order for us to solve this one, we can subtract 1 from each side. We get tangent x radical 3 tangent x becomes negative 1. Then tangent x will be equal to negative 1 over radical 3. When you multiply top and bottom by radical 3, we end up getting negative radical 3 over 3. This refers to the reference angle of 30 degrees. But since tangent is negative, then we are looking at second and fourth quadrant. That means if you're to be over here, then the angle, since the reference angle is 30, this will be 150, which is our answer. Alright, when do you have sine and cosine to be equal to each other? Now, this basically means, first of all, they have to have the same sign. And since they're equal to each other, that we know that by the co-function idea, we have 2x, x plus x has to be equal to 90, then x has to be equal to 45. So we get to realize that 45 is true. But they can be both negative, which means 225 degrees is also correct. So therefore, choice 2 becomes our answer. The next question here. 10 minutes or nearest tenth of a degree. So since obviously this one doesn't seem to be satisfying things by hand, so what we're going to do is we're going to use the calculator. So here we have, first one becomes 4 sine x squared plus 1. So left side, I'm going to put that into y sub 1. Right side, I'm going to put that into y sub 2. So sine of x squared plus 2. Now, I'm going to set the window as 0 through 360. And I'm going to go for zoom fit, which will be equal to 0. That's the first one. And as you can see, we have 4 locations. 1, 2, 3, 4. Find all values. How are we going to find them? By using the second calc, intersect, number 5. First curve, let's come closer to the where we want to find the intersection of. Alright, that's the first curve. Second curve. Guess? Yes. So the first angle was 35.3 degrees. Now let's go for the second one. Same thing, second calc, number 5, first, second, and right before we guess, we just have to get closer to the intersection which we are looking for. That was 144.7. Now the third one, second calc, number 5, second curve, guess, we just want to look at it a closer to our intersection, so there it goes, 215.3. The last one. First, second, guess, right before we guess, we just have to get near the points that we want. It was 324.7 degrees. Alright, those are our answers using the graphing. Solve for the smallest non-negative value of angle theta. So here we have, what we can do is we can square both sides, and we end up getting 3 cosine theta plus 1 equals 4. By subtracting 1, we get to realize that cosine theta has to be ultimately equal to 1. When do you have cosine theta equal to 1? When the theta is equal to 0. That's it. Or 360 degrees. But here we have non-negative value of theta. So 0 is non-negative. There it goes. Which satisfies a given equation. Here we have 7 cosine theta plus 1. Since we know that the secant is 1 over cosine, so we're going to have 6 over cosine theta. We can multiply left and right side everything by the cosine. Then we get to realize 7 cosine square theta plus cosine theta equals 6. By subtracting 6, we get to realize that 7 cosine square theta plus cosine theta minus 6 equal to 0. And here we should be able to factor this one. 7 cosine theta and cosine theta. Somehow 6 has to be distributed into both cases to make that into positive, so we could have positive 1, negative 6. Then here we have cosine theta can be equal to 6 over 7. That's one such case. The other case is cosine theta has to be equal to negative 1. This is rather easy because this cosine of pi, or rather 180 degrees, will get us the answer. How about here? We're going to go for, to find the angle, what we're going to be doing is second cosine of 6 divided by 7. Then we'll end up getting our answer, which is 31 degrees. But cosine would be positive also in the fourth quadrant, so therefore another value would have been 360 minus 31, which is 329 degrees. So we have 3 values here. Find the nearest degree. So this sounds like a nice question for us to do with your calculator. Six sine x square minus sine x. I can simply subtract 2 from both sides and set it equal to 0. Now once again, window is that okay, zoom fit 0. So we have 1, 2, 3, 4 values. We're going to calculate that by second calc. Zeros. Now since we are looking for the all 4 values, I have to move to the left of the left bound. Press that, and then right of the right side of the intersection that we are looking at. And that's our first answer. 41.8 degrees. But to the nearest degree, so this implies to 42 degrees. Now, second one. Zero. We have to pass that point to the right bound, and it became 138. So and then we have to look for 2 more. Finding the 0. And we just have to pass that. 210 degrees. The last one. Number 2. Right bound has to be past that once again. And 330. Alright, let's continue. Find the value of theta from 90 to 270. So 90 to 270, we're talking about second and third quadrant. That satisfies this condition. So we have sine theta will be in fact equal to -1/2. When do you have sine theta to be -1/2? It's only possible on the third quadrant, where theta, the reference angle, will be equal to 30 degrees. So we end up looking at 215 degrees. That becomes our answer. No, I mean not 215, 210. Sorry about that. All right. How about this one? We end up getting sine x will be equal to radical 2, because we're adding radical 2 on both sides, divided by 2. That means x has to be equal to 45 degrees. Smallest positive angle that satisfies this equation. So that means we're going to subtract 1 from each side. You'll realize that cosine of x must be equal to -1/2. That means x has to be equal to reference angle being 30 degrees. I mean the reference angle being 60 degrees in case of cosine. Then we end up getting 120 degrees. That becomes our answer. Exact value of sine of 75. Sine of 75 is essentially equal to sine of 30 plus 45. Now, assuming that each one is degrees, this basically means sine of 30 degrees times cosine of 45 by the formula, plus sine of 45 degrees times cosine of 30 degrees. Now then let's look at it. Sine of 30 becomes 1/2 times square root of 2/2, here plus square root of 2/2, and then the last one becomes square root of 3/2. Then what happened? Denominator becomes 4 in either way. On the first part we have square root of 2, plus second part we have square root of 6, and that becomes our answer. Alright, we want to prove the following identity. One of the best things for us to do is expressing everything in terms of sine and cosine. Now, then one thing that which we can do is this. On the left side here we have sine theta all over sine squared theta, and then in fact if you think about it, this is equal to plus 1 minus 2 sine squared theta. Then here we end up getting sine theta over 1 minus sine theta, sine squared theta. What is that? In fact, 1 minus sine squared? Yes, that's right. Sine theta over cosine squared theta. But what is that in fact? Yes, if you're to rewrite this one, then this will be equal to 1 over cosine theta times 1 over cosine theta over sine theta. So here we have, this portion becomes secant theta over cotangent theta, which is equal to our choice. How about the second one? That's right. So here we have left side becomes sine square x plus cosine square x, but plus 2 sine x and then cosine x minus 1 all over cosine x. But one cancels out with sine square plus cosine square x. And then cosine x cancels out here. We only have 2 sine of x. That's what's left on the left side. How about the right side? Then here we have 2 sine x cosine x times tangent is sine x over cosine of x, and cosecant is 1 over sine of x. Then let us see what happens. Here sine x cancels out, cosine x cancels out. That's right, 2 sine x is left, so is the other side. Alright, how about this one? Here we have this becomes sine x over cosine x plus cosine x over sine x. The fact that you want to make this one into one fraction so that we could only have one thing on the other side, we end up getting sine x times cosine of x. That becomes our denominator, and then here we end up multiplying by sine square x plus cosine square x. On the top it becomes 1 over sine of x cosine of x. But 1 over sine becomes cosecant. X times 1 over cosine becomes secant x. And that is exactly what we have on the other side. Alright, we have just 2 more questions to go. Number 36. Find cosine of 2a. Now cosine of 2a is equal to 1 minus 2 sine square of a. But what is sine of a? That's equal to 2/3. So here we have 1 minus 2 times 2/3 square, which ends up being 1 minus 2 times 4 over 9, which becomes 1 over 9 becomes our final answer. Alright, so we have quadrant 2, and then cosine is negative, as you can see. How about the exact value of sine of 2 theta? Sine of 2 theta is in fact equal to 2 sine theta and then cosine theta. Now cosine theta, we know the value already. 2 is okay. What is sine theta? Sine theta, in fact, if you have to draw the triangle here, given that this is theta, without the sine, in fact, this becomes cosine is 3 and hypotenuse becomes 4. Then this side, in fact, becomes square root of 7. You can use the Pythagorean theorem to verify this one. Then here, what is a sine theta? Has to be equal to negative radical 7 over 4. No, I mean positive, because it's on the second quadrant. So we do have all the values, so let's put them in together and see what happens. It's equal to 2 times radical 7 over 4 times negative 3 over 4. Then here we have negative 3 radical 7 over, now 4 cancels with, 2 cancels with 1 over 4, so we end up getting 8. Negative 3 radical 7 over 8. That becomes our answer. Here we have 0 through 360. Nearest degrees, so in fact what we're going to be doing is we're going to use the calculator once again. Here we have 2 sine x, and then we're going to square that, minus 4 sine of x. That's the first line. Second line has to be equal to cosine square. So in this case, cosine x, close the parenthesis, square, and then minus 2. Once again, window becomes 0 through 60, okay. And if you to graph it, So in fact, what we're going to be doing is we're going to go for zoom fit once again to see the better picture. So if I have to bring this one in, you will see that when are they equal? They are equal over here, and around here, and over here. Those are the three seemingly places. Let's see what happens. First, let's try to calculate the intersect, which is the number 5. First curve, yes. That's the second curve, yes. Guess. That's right. The last value, in fact, was 160.5. Nearest degree, so 161. How about the middle one? Same question. Intersect number 5. And then I want you to guess around here. I think it went back, so let's try to go to the, oh, how about this one? We'll try to come near here. And then we're gonna have intersect number 5. First curve, second curve, yes. Okay. Somehow just keep on going over there. Let's try to go. I'm gonna try to go here and then zoom in, and then we'll see things a bit better. So let me just set up the window a little bit more. So I'm gonna just say 20 degrees and 120. So we're looking for that value. That's one value, 90 degrees. And we just have to find that value. I'm going closer to the intersection. Okay, I guess we have to go a little bit further. I'm just going to go for 10. Then we should be able to see the sign change right over there. Okay, good. Second, and number 5. Get closer to it. Yes, that's the first curve. That's the second curve. And I want you to guess it over there. Yes. So it's 19 degrees. The third one is 19 degrees. That's how we can calculate each one. All right. I'll see you later. Bye-bye.